All right, so what I'd like to do is continue with modeling a sneeze. So I collected all my data and I'm going to show you that one sheet of paper where all of my dots landed. All right, so I actually need to zoom out a little bit here. So this is what I collected, right? And so what you can see, so if you imagine, right, this was on the floor, the spray bottle was back towards me, right? So the stream of my sneeze went in this direction towards the top of the screen. Okay, so what I did was measure from the spray bottle to this point, and that was 90 centimeters. So I drew that line there. And then I measured every single one of these little dots. So below that line, right, I subtracted, and these were 87.5 centimeters from the spray bottle, so on and so forth. And then above that line, right, these numbers are upside down, but I measured each one of these from that line, right, and added whatever distance from that 90 centimeters. Okay, so this was all of my data. And then what I did was find the average. And even just looking at this, you can see a high concentration of dots up in here. So my average came out to be 113.75 centimeters. So I'm going to write that here. My average was 113.75 centimeters. This was my average distance in the x direction. Okay. The other thing that I did was I wrote down here the height of the spray bottle. So that's something that you need, right? I didn't mention that in that first video, but you need the height of the spray bottle from the ground up. So this will be my dy, right? Distance in the y direction, and that was 27 centimeters. So these are two values that I'm going to need in order to determine our overall conclusion here, right? Is 6 feet far enough? So I'm going to take those values and I'm going to now start essentially creating a data table and a space where I'm going to do all of my calculations, right? And so this is something that you're going to want to definitely write out somewhere on a nice sheet of paper that you can take a picture of or that you can put in a Google Doc and send as you turn in your lab. Okay? So my initial data, the first thing I had here was the distance in the y direction. That's the height of the spray bottle. This was 27 centimeters, right? And so I'm going to convert that to meters, divide by 100, so 0.27 meters. Okay, and as a side note here, I'm going to write down that this was the height of the spray bottle. Right? So measured from the ground up to wherever those sneeze particles were coming out. The other piece of data that we just collected was measuring all those little dots. And so that's the distance in the x direction. And my average is what I'm going to use. So my average was 113.75 centimeters. Okay. Your average will be different. So your values here will be different, but they should be the measurement of the same quantity, right? The height of the bottle or the distance where the particles landed. So again, I'm going to convert this to meters, divide by 100. So 1.1375 meters. And again, I'm just going to make note here that this is the distance horizontally this is a horizontal distance of the average landing place. Let's say landing spot of a sneeze particle. Right? So those are all the things that I measured. And so now what I want to do, I'm going to draw a picture, right? I like pictures. I'm going to draw, essentially what we did here is we had our spray bottle, right? Here's the height of my spray bottle, so this is dy, right? Here we can say, here's the nozzle, right, where the particles are coming out. And then I have this distance in the x direction where all those particles landed, right? And so remember, you want to make this a 0-degree angle so that they're coming out in this direction. So this will be the initial velocity in the x direction. Okay? So when they come out, they're following the path of a projectile and they land somewhere over here, where in my data, that distance, right, this is 1.1375 meters. And my dy in my data is 0.27 meters. Okay, so that's what I have going on here. Now, what we want to do is determine this value, right? This is our big unknown. So we want to figure out how fast are those particles traveling when they come out of the spray bottle. Essentially, when you sneeze, how fast are those particles moving? So I'm going to create a nice big XY chart. Remember these? And I'm going to label things that we know. So I know the distance in the y direction. So this is dy. And I know that this is 0.27 meters. I also know the distance in the x direction is 1.1375 meters. Okay. And I know that I'm looking for initial velocity in the x direction. That's my question. Now, if you remember projectiles, what causes those particles to fall to the ground, right? They're coming out and they're moving horizontally. What causes them to fall down? Gravity. And we know gravity works in the y direction. So the acceleration in the y direction is 9.81 meters per second squared. The other thing we know, since we set this at 0 degrees, the initial velocity in the y direction is 0. Okay. The other thing to take note of, for every projectile, acceleration in the x direction is always 0. Okay. So if you remember projectiles, the very first thing we typically do is find the time, because time can be used on both sides, right? It takes the same amount of time for things to fall to the ground. So I'm going to find time on the y side because that's where I have the most information. So if you pull out your reference tables and go back to that kinematics page, the very last page, we're going to use an equation that has all 4 of these variables, d, a, v, and t. And that is the distance equation. Okay. So I'm going to use the distance equation on the y side, and I'm going to put little y's in here. So dy equals vi in the y direction times t plus 1/2 ay times t squared. Okay, now initial velocity in the y direction is 0, and so now I'm going to start plugging my numbers in, right? So you have to plug your own numbers in. So distance in the y direction was 0.27 meters equals 1/2 times acceleration due to gravity, 9.81 meters per second squared, times t squared. Right, so then you have to solve for t. Don't forget to take the square root. Right, so I'm going to do my math real quick here. So I get a time of 0.23 seconds. So that's how long it took the particles to leave the spray bottle and fall to the ground. And so this time I can now bring over on the other side. So the time in the x direction is also 0.23 seconds. And now I can use an equation to find how fast those particles leave the spray bottle. Right? So again, this is the distance equation, but with x values. So dx equals vi in the x direction times t plus 1/2 times a in the x direction times t squared. But remember, acceleration in the x direction is 0, so this goes away. So I have 1.1375 meters equals vi in the x direction times 0.23 seconds. And now again, remember, these are my values. Your values are going to be different. And so when I solve, I get an initial velocity of 4.95 meters per second. So this is a value that you need, right? So this is the initial velocity of a sneeze particle, right? We're modeling that, right? But that's the velocity of a sneeze particle. So when you sneeze, the particles that come out of your mouth are traveling roughly 4.95 meters per second. So they move 4.9, almost 5 meters every second. Okay, now we did this kind of on a scaled down model. So we need to apply this now to humans, right? And so the next piece of this is to think about when a human actually sneezes. Okay, so this is your data collection, and you started to calculate, right? You did calculate the average velocity of that particle. And now we're going to apply this to humans, right? And so I'm going to actually do one more calculation, and then this will help you draw your conclusion, right? So this is my calculation section of this activity. Right? And so what we need to do is model this as a human. So let's draw a picture. I love drawing pictures. Right, so here's the ground. We're going to draw a person. Right, so here's my stick figure. I know that you've missed my drawings. Right, so here's the person, and this person is happy. Give him some hair, but he's sick, and so he is going to sneeze. And all of these particles, right, when he sneezes, all these particles are going to be coming out of his mouth. And so those particles are traveling at the velocity that we just calculated. So my initial velocity comes from what I did in my data collection. So my initial velocity is 4.95 meters per second. Okay, and so what we need to do is determine how far those particles are going to travel. So when you sneeze, those particles are going to be projected horizontally, but we know that gravity is also going to start to pull them down. Okay, and you need to determine this distance in the x direction. Where will they land, right? So from wherever you sneeze, how far are those particles going to land? Now, the other thing we have to consider is the height of this person. So we're going to use an average, right? So we'll call this dy. This is my vertical height. On average, we'll say that typical humans are roughly, I don't know, let's do like 5 feet 8 inches, right? So we've got a wide range there. We know some people are taller than 6 feet. Some people are definitely my size, right? 5'3". So we'll say on average 5 feet, I'm just going to write this here, 5 feet 8 inches. That's what we're going to use. Okay, but we have to convert that to meters. So I've done that conversion for you, so you don't have to do that. That's roughly 1.73 meters. Okay, and so we're going to say that that is the average human height. So here's where your calculations come into play. You need to determine what this distance is. So what I recommend that you do is make an XY chart and follow a very similar process as to what we did in the data collection. So I'm going to label things that I know here. I'm looking for dx. I know the initial velocity because this is the value that you got in your data collection. So my personal value is 4.95 meters per second. Yours will be different, right? So I'm going to put a little star next to this. This is your value. Use your numbers. Okay. The other thing I know is the distance in the y direction. I just gave you that, right? We're going to use 1.73 meters as the typical average human height. We know that those particles accelerate due to gravity, so this is 9.81 meters per second squared. And we're just going to consider that they come out of your mouth at a horizontal angle here. So VIY is 0. We're not going to make it any more complicated than it needs to be. Okay. The other thing to remember, acceleration in the x direction is always 0. So the very first thing you want to do is find the time on the y side. Once you do that, right, once you get this time, it's equal to whatever it is. Show your work. Then you're going to bring that over here, right, whatever that is, and then you can solve for your distance. Okay, so you are going to get a distance in meters, but we need to convert that to feet. So when you get your distance, right, so this is your final step here, you have to convert your distance into feet. Right? So again, whatever distance you get here, you have to convert that distance into feet, right? Because you'll get a value in meters. And so to do that, you're going to take your number. I'm going to just give you an example. So let's take, I don't know, 2 meters, right? So if my distance in the x direction was 2 meters, that's not what I would get when I do this calculation, right? But if it was 2 meters, I'm going to take 2 meters and I'm going to multiply by this conversion factor, which is, I'm going to put meters on the bottom, feet on the top. For every 1 meter, there are 3.28 feet in that meter. So essentially, right, this is like being over 1. I'm just going to multiply. So really what you're doing is taking your distance and multiplying by 3.28 feet per meter, and your meters are going to cancel. So if I were to do this right now, if my distance was 2 meters, I'm going to take 3.28 and multiply by my distance. So I get a distance of 6.56 feet. Oh, wow. I didn't do that on purpose, right? So I would get a distance of roughly 6 feet, but this is just an example, right? You probably will get a number that's different than this, okay? And so that's your final answer. And from there, you're going to draw your conclusions and come up with a recommendation about how far away we should stand based on whatever number you got here. Okay, now again, this is not the number you'll get, right? So give your recommendation based on your distance calculation. Right, so again, your number, your recommendation will be different than whatever mine would be. It'll be different than whatever your friend would be because you're going to have different data, right? But they should be pretty similar. Right? So give that a shot. Definitely rewind the videos, pause the videos, follow the work. If you need any help at all as you're doing this, please get in touch with me. I'm happy to help.